So question number 2 asks you to use Coulomb's law to determine whether ionic bonds are stronger in water or in hexane. Explain your answer using the equation and chemical logic. So the equation for Coulomb's law is shown here. Now, the key part of this equation, all right, so I'll go through the unimportant parts real quick. Unimportant parts are this constant K, the Q1 and Q2, which are the charges, and R, which is the radius between them. All right, none of those things are affected by the solvent. All right, the part that is affected by the solvent is D here. So D is something called the dielectric constant. So for a polar solvent, D is a large number. For a nonpolar solvent, D is small. All right, now, what is the effect of having either a big number or a small number on U? So U is the energy of attraction or repulsion between our two ionic charges. So with a big D, we would then have a large number in the denominator here, and so that's going to result in a small U. So small force of attraction between the components of an ionic bond. All right, now conversely, if we have a small number in the denominator, that tends to increase U. So for our polar solvent, we will have relatively weak amount of energy holding together the ionic the ions, I guess. In a nonpolar solvent, the attractive energy is going to be much larger. All right, now what's some evidence for this? So that's what the equation tells us. So that's part of the answer here. All right, the second part is chemical logic. Well, what happens when we take salt and put it into water? Well, it dissolves, right? So it breaks up into sodium ions and chloride ions. Conversely, if we take salt and try to dissolve it in hexane, it won't dissolve. All right, the salt will remain in a crystalline form. Well, what does that tell us about the relative strength of those bonds? Well, it suggests that the bonds are easier to break in the presence of water. So it implies that in the polar solvent, the force holding together the sodium and the chloride ions is less than it is in the nonpolar solvent. Right? Because in the nonpolar solvent, we can't pull them apart. All right, now the logic isn't fully fleshed out because obviously the bonds between the ions and the solvent also do play a role here, but you can still kind of see this phenomena when you start to reason through what actually happens when you try to dissolve an ionic compound into one of these two solvents.